Have you ever wondered how does a tiny bird launch into a tower to knock over some pigs? Well then, we are going to show you through this demonstration of projectile motion with Angry Birds.
To start, we need to know what projectile motion is. A projectile is a body or object projected to impel forward as through the air. So by definition, projectile motion is the act of calculating the launch path and velocities of a projectile. In our demonstration, said projectile will be this red bird and its target will be this tower.
Projectile motion can be charted using this table layout. Everything in the x column is motion, or distance in the x direction, or horizontal direction. Everything in the y column is the vertical direction. VI stands for initial velocity, VF is final velocity, A is acceleration due to gravity, T is time, and x or y is the distance in the given direction.
Now that we know the basic information, we can examine our problem and begin to solve it. In the Angry Birds games, you can fling your bird at any angle to hit whatever target you need. For our demonstration, said the bird is going to be flung at a 45-degree angle to hit the tower 20 feet away, and will be launching at 24 feet per second. We want to know what is the peak height that the bird will reach before descending upon the poor piggy tower.
Firstly, we fill in the information we already know. The distance between the bird and the tower is 20 feet, so we mark down 20 here. Next, we make a side note that the bird is being launched at 24 feet per second at 45 degrees. We will use these numbers in just a second. Lastly, we know that the acceleration due to gravity is 9.8 meters per second squared, but since our distance is in feet, we convert this number to 32 feet per second squared. And since gravity pulls down, we write the number in as negative 32 feet per second squared.
To find the bird's initial and final velocities, we need to use the known speed and angle in separate equations. First, we put the speed and given angle into the form of a triangle to represent the launch. For the x direction, we use velocity times cosine times the angle. And y, we use the velocity times sine times the angle. For the x direction, we get 16.97 feet per second and 16.97 feet per second in the y direction.
Now that we have this information, we can find the peak height of the bird. We first need to find the time, which we do so with the equation x equals vi times t plus half at squared. Since a in the x direction is 0, this half of the equation disappears, leaving x equals vi times t. Solving the problem down gives us a time of 1.17 seconds. This time now converts over to the other side, as time will not change in either direction.
Now with the time in the y direction, we can solve for the peak height. We take the equation y equals vi times t plus 1/2 times a times t squared. Solve the problem down and get the answer 1.13 feet. We then take this number and divide it in half to give us a peak height of 0.56 feet. This means that when the bird reaches here in its launch path, it is at its maximum height of 0.56 feet. And now for the fun part of Angry Birds, destroy the fortress.